So according to the Ohm's
Pardon?
law, like to understand the Ohm's law, it's very much important to know what's current and what's potential difference. That's why I've asked you. Okay.
Yeah, yeah, of course, yeah.
Okay. Now, according to the Ohm's law, in a given circuit, potential difference is directly proportional to the current, provided current temperature remains same. That's very important. When you're talking about law, when we are writing something about law, law should be very much precise. The statement should be very much precise. So according to the Ohm's law, potential difference is directly proportional to the current, provided temperature remains constant.
Okay, so potential difference is directly proportional to current,
Yes.
provide that
Temperature,
temperature stays,
yes, temperature remains the same, or temperature remains
but
constant.
then by like V, like proportional to like I, like what does that mean exactly? Because isn't V volume?
V is potential difference.
Okay, so it can mean volume or potential difference.
Yes, because potential difference in current electricity we denote it with V.
Okay, the other one it's like V over something, isn't it?
Its V is directly proportional to I. That is, potential difference is directly proportional to the current. That is actually.
Okay. So this means that the potential difference is directly,
Proportional to current.
yeah, directly proportional to current. Okay, so provided that the temperature is constant.
Yes.
So this, like, it means that it will only happen if the temperature is constant.
Yes.
Okay.
So since it's proportionality, and whenever we remove the proportionality, we introduce a constant, right?
Yeah.
So this is V is equals to, and the constant in this case is R. So V equals RI.
So what do you mean, like
R is
const?
constant, which
So
is,
like R is
yes, yes, you
the
can,
constant.
yes, R is a constant, which is resistance.
Okay. So this, so basically potential difference is directly proportional to the current if the temperature is constant and the resistance is constant, or no, is that something else, the resistance
Like
that you're
law
talking?
is, this is the law, that is potential difference is directly proportional to the current provided temperature remains constant. This is law. Okay, and that is the statement ends there. Okay, now whenever we write in mathematical form, if we are writing that law in a mathematical form, it's V is directly proportional to I. Okay, and
Okay, so this is just the form which you write it in,
yes,
like equation. Okay. Right. And does it, by the way, like matter what order it's in, like R and I or I and R?
like it doesn't matter if you're writing V equals IR or V equals RI, it's the same.
Yeah, yeah, because I think I just remember, like, I think I remember, like, not recently, but like at one point we did do like a few of the equations, but like we weren't like really going into that much of the depth of it. Like, it was just very basic, and it was like V equals to IR or something. So I'm just asking if it's like the same thing,
Yeah,
if
yeah,
it's, if the,
yes, exactly, it's the same.
okay, right. And so R is resistance, and then the I is current,
Yes,
and the V is the,
potential difference.
hello?
V is potential difference.
Okay, yeah. Sorry, yeah. And I'm just asking like a general question, like here, like, not just in this, but like sometimes in some maths equations, even like some maths equations, but like in physics, there tends to be like whenever like we do equations, I don't know if I can write on this white screen just to like ask you kind of a question about it, like just to show what I mean.
Okay, you can
So
write
like
it.
by like for this, like I'm just asking if like this is kind of like, if I just draw it, it'll make more sense. Like we tend to like have like triangles kind of
Yes, and
sometimes. And I'm just like asking just for not for the specific one, but like for usually like most of or nearly all of the equations, like whenever it's like something like I don't know, even like I don't know like what this is, I'm just making it up, like S equals to let's say B or C or something,
okay.
then whatever this that will be on the top, and then B and C will be like here, right? So that's like how I will like know kind of.
Yes.
What I'm saying is like would like any kind of like this kind of equation I could like put it into like a triangle form, right? Like if I was just to remember it. Like
Yes.
we'll have it in the booklet anyway, but I was just asking if it can like be done in like triangle kind of form, just
Yes.
because that's used to tend that we tend to use that like quite a bit. So I was just asking about that, if
Yeah.
that works for really any equation.
Yes. Yes. It will.
Okay, yeah, I've copied the like formula down.
Okay. Now the next is resistance, because by Ohm's law we get to know exactly the resistances, like what's the role of resistance in a given circuit. So from resistance, from here we can say resistance is what the definition is. Resistance is a property of material. Basically it's property of material
Yeah.
that obstructs a flow of current. I can try to just write that down. So property of material which resists the flow of current or which obstructs the flow of current.
Okay, so resistance is a property of material that obstructs the
Flow of
flow
current.
of current,
Yes.
or
Which
you're
resists the flow
saying.
or resist the flow.
So, oh, are you meaning like resistance is a property of a material that obstructs the flow of current, which resists the flow? Is
No,
that what you just?
no, which obstructs the flow of current, or or you can say which resists the flow of current. Both means the same.
Okay,
Obstruct or
like
yes.
okay, so it's just like different words. Okay, okay,
Yes.
okay, yeah, I've copied it down.
Okay, and this is the definition of resistance. That's why resistance and current are inversely proportional to each other.
Yeah, that makes sense. So, like, one's trying to go one way and the other is going the other, right? Like, if one goes up, the other will go down.
Yes.
Okay.
And
Um. So for this, um, like, is this like? Did you put one over I?
is inversely, like it's proportionality. Otherwise, it's like this. We get this from here. So you can write I equals V over R.
Okay, so it's just okay. I understand. So this just means that it's inversely okay. Yeah. Yeah, I've copied it down. So it's inversely proportional to
Yes.
each
So
other.
the unit of resistance is ohms.
Okay, so units of resistance is ohms.
Yes.
Yeah, and that's like that horseshoe kind of shape, isn't it? Like,
Yeah, like this.
else kind of, it's like, yeah, yeah, that kind of shape.
Like this.
Okay, yeah.
So there is one
And
question. Yes, yes.
the potential difference, what's the unit of that again? Is that just
Volts. Volts,
I
volts.
mean, oh, volts, okay, okay. So that's just V.
Yes.
Okay, yeah. You were saying?
Yes, so I was giving you one question to solve. Honestly. So it's given as potential difference is 200 volts. Potential difference is 200 volts when 100 coulomb of charges flows in 20 seconds. Calculate the resistance.
Okay, but like, so the potential difference at first of all that be 200, but then it's saying, so the other thing is the current and
Yes.
the, we have to find out the resistance. So because of that, would I use the other equation to find out the um to
Current.
find out the charge time and then at current, yeah.
Yes.
So I need to find I would need to do I equals to, I think it's Q over T.
Yes.
Okay, so I equals to, well, first of all, I'd write the proper equation for it, which would be Q equals to IT, and
Yes.
then it would be, so I equals to Q over T, which means I equals to then 100 over 20,
Yes.
which would then give you the answer of 5. So when the current is then 5A, so 5 amps. So then 5A, okay. So therefore V equals to IR. So then, since I'm trying to find the resistance, that would be R equals to V over I,
Yes.
and then R equals to 200 over 5,
Yes.
which would give me R equals to 40.
Yes. Yes.
40 ohms. Yeah. Okay, yeah. Is it 40 ohms?
Yes, that's correct. That's 40 minutes.
Okay.
Okay, now after this, let me see how to plot this, like the graph.
Pardon? Hello?
Yeah, I'm plotting a graph of Ohm's law. Okay?
Okay, I just didn't hear like completely what you said for a second because it was just cut. Okay.
Okay.
So is this graph for just like, okay, just like a plain line graph, or
Yeah, just a graph where you see the curve. So V equals RI, and here we plot V, and here it's I.
one second. So basically, so this graph, so I'd have to, that's where the potential difference is, and on the x is where the current is.
Okay. And it will be much simpler if I put this I here and V there. In both ways we can plot this graph. Doesn't matter.
Okay, so it doesn't matter, you're just like showing an example.
Yeah, this is for like whether you are writing voltage here or current here, voltage here, in both ways you are going to get the same curve that I'm saying. Okay.
Okay, but like same kind
Yeah,
of
but yeah, that's not always the
information
case.
you.
This is current and this is voltage.
But you're saying though, like if like unless like if it doesn't specifically say like where to put like on what axis which one, then you're
Yes,
saying it doesn't matter if I put the current on the y or the x.
yes, but curve should be the correct. Okay, that means if you're putting current there and voltage here, if you change the axis, it doesn't matter if you're changing the axis, it's no wrong. But thing is, if you change the axis, the graph changes. That's the main thing. Okay, but in
Yeah,
case,
so yeah, like the information shown on it changes.
so the graph is like this, a very straight, passing through this origin.
Okay, so 1 second. So basically, this is just to show that well, since it's going through a straight line from the origin, is that to show like as current increases,
Voltage increases. They are directly
as
proportional.
voltage increases, yeah, then the current. So wait, I'm not really sure. So what is this supposed to show?
This
Like as
shows like this is the slope, that is resistance.
yeah, so that okay, yeah, that is resistance. Like what I mean as in so what happens? So yeah, current and voltage, they are like wait,
Directly,
not
directly proportional.
yeah, this is not potential difference, is it?
Voltage or potential difference is the same. Like V voltage or potential difference is the same. Yeah.
Okay. Okay, so it's the same thing. Okay. Okay, so then that means that current and potential difference, they are also inversely proportional, and so is current and voltage.
They are directly, current and voltage are directly proportional to each other.
Okay, okay, yeah. So it's a resistance in current that's inversely proportional.
Yes,
Okay, so these two like are directly proportional.
yes, that's
Okay, yeah.
it. Okay. Now, since we are studying the graphs, so there are three more graphs that are very much important. So you have noted this, right?
Yeah, so this means like as current increases, resistance increases, right?
Yes. So this is also a graph called ohmic conductor or ohmic resistor.
Okay, I'll just copy that down as. So would it like matter on a test like if we didn't exactly specify like like what I'm trying to say is if like I put voltage instead of potential difference or potential difference instead of voltage.
Yeah, it doesn't matter. It remains the same. But generally, it's a graph between voltage and current. That's why we use voltage.
Okay, so this is an ohmic conductor graph. Like
Yes.
okay, yeah, I've written it down.
Okay, now the next graph is first graph is for light bulb or lamp. Yes,
Sorry, what did you say?
it's for lamp or light bulb.
Oh, light. Okay.
Bulb. It's a non-ohmic. Okay, these all are those conductors that have a straight line are always the ohmic conductor. That means they follows the Ohm's law. It's not necessary that every component follows the Ohm's law. The light bulb do not follow the Ohm's law. So it's a graph of voltage V and R.
Okay, so this shows that. So basically, so because wait, so light bulb isn't what? Sorry, what did you say it was in?
It's not an ohmic conductor. It doesn't follow Ohm's law.
Okay, it doesn't follow ohmic law. And how do you tell if something follows ohmic law? Like just by the equation and
Yeah, if it's an ohmic conductor, we use V equals R. But it's something which is not an ohmic conductor, we can't use the equation V equals R.
okay, it doesn't follow the ohmic law, so it's not an ohmic conductor.
Yes.
So that's why um when you see using like a light bulb, that's why the current is so what would you say then this is though? So this is like as current increases,
Yeah, current,
but
you can see still voltage is, when voltage increases, current is increasing, or current is increasing, voltage is increasing. That's correct. But it's not increasing linearly. Okay?
yes, okay, yeah, I get it. So it's not increasing like in the right way that it's supposed to, obviously.
Yeah.
Okay, yeah, I've written it down.
And the next is, this one is for diode. So for this is also V, R.
Okay, so diode, it is kind of following it, but still not in the way that it's supposed to. So this is like when it like as the diode is kind of
Like
uh
potential
like
difference or voltage is not increasing. It is, but like it's very small amount of voltage is increasing as current increases. Right? Current keeps on increasing, but voltage is not increasing in that amount as it should happen with the light bulbs and with all of the devices. Right?
yeah, okay. So like yeah, so like for I is not like as it's supposed to be, right?
Yeah.
That's why in that one. And in this one it's because V is not how it's supposed to be. But like generally like everything really how it works.
Yes.
That's why it's not.
Yes.
Okay.
Okay, now
So sorry, but what is a diode? Is that like um
diode
what
is,
is
yes. So diode is basically, first of all important, it's a conductor that conducts a current only in one direction. Okay, and generally these are diodes are used in electronic items, like say for example in LEDs, in televisions like LEDs,
oh
LCDs,
yes,
or in
that's where I remember it from.
yeah,
Yeah, okay, so is it like yeah, so like screens kind of mostly to do with that.
yes. So like light emitting diodes, LED, right? LEDs are light emitting diodes.
Okay, so an LED is a light emitting diode. Okay, yeah, so basically things to do with that.
Yes.
Okay.
So So like in
So again,
electronic systems, so the conductors that are used are basically diodes.
okay. So like trying to use to like a phone or like a TV or something,
Yes.
or even maybe even a computer, right?
Yes.
Okay, and this is also, not going the right way because it's not an ohmic conductor.
Yes, it's not on the conductor.
Okay, because as you said it was only going resistance was only going in one way, or did you say
Current.
something? The
Current.
current, yeah,
Yes.
only so going one way. So like normally is like the current is it able to go like both of the ways, like or
Yeah, and like other materials, because the lamps or that we use that we can't use in electronic systems. So electronic system has a whole different thing like the diodes and all that capacitance and all the things that they have. So it's a whole different thing. Okay.
okay, so it's like a bit more of a
Yes.
big topic. So
Yes.
but basically like
This is
it's because they're only
and you
going
have to
one way, but
remember.
like
Yes. Yes. So one thing you have to remember, this is between V and I. Okay. If you change I and V here, the graph will change. So this is between V and I. I is on x-axis and Y on y-axis. V on y-axis.
yeah, yeah, I get it. Because then, like, yeah, of how like it looks, it's gonna look different. Okay, yeah. So basically, just remember to keep it this way,
Yes.
like in this order.
Yes.
Okay, yeah. But like for like when it says conductor current only going in one way in a diode, like I'm speaking about like what would an ohmic conductor go in then? Like the current, would it go in like just nor like how
It's
would that just
also
if
like it's in ohmic conductor. It's also one way because generally it's the DC circuit that we use, and DC is a direct current, which means when the current has only one direction. Okay. When
okay, so
when we'll study
this is like
DC and yes, yes. So when we'll study DC and AC, you get to know about this in detail, right?
okay, so this is just basically because of like other things related with diodes as
Yes,
well.
yes,
Okay, okay, yeah. So moving on to the other one.
yes. The last one is thermistor. So thermistor are the kind of resistors whose resistance changes according to the temperature. If you change even a slight temperature, say for example it's 22 degrees and you change it to 23 degrees, a visible amount of resistance will change. Such type of resistors are known as thermistors.
Wait, I didn't hear like what the thing you said it was. So what was
Yes,
it?
yes,
The
yes, yes, I'm repeating it again. First of all, thermistor. Thermistor, which means temperature.
yeah, yeah, I just didn't hear it because it just keeps on cutting.
Okay. So the resistor that keeps on changing their resistance with the change in temperature are called thermistors.
Okay, so these are resistors that keep changing due to different temperatures or no? Like
Due to change in temperature.
okay, right. And how does the graph look in this?
Yes. So the graph looks like this. It goes like this.
Okay, so this would be
Wait a minute,
like
let me
this.
draw this once again. It's like this.
So this is also not an ohmic conductor.
Yeah.
Okay, and is V supposed to be on the y-axis and X is like that's supposed to be I, right?
Yes, this is V and this is I.
Okay. And I'm just asking, are like, why are like these like, you know, Like not just in like important, but like is this like something like mostly that comes on tests, or is just this like just showing kind of me like if
No,
it's like this
generally
then?
in the questions, this gives you. Like the questions
Oh,
are in match the column, or the questions are like you just have to write this is the graph of which component. Questions are generally like this.
okay, okay, yeah, I understand now. Yeah, okay. So yeah, I've drawn that one as well.
I agree. Now it's series and parallel circuit. So I'm starting with series circuit.
Okay.
Suppose this is a circuit.
By the way, not today, but like maybe in a next lesson as well. And I'm just asking, like if since like we are supposed to know like different types of symbols and things, maybe if we go over them like
Yes,
in
yes,
next
yes.
lesson,
Yes, yes, definitely, definitely.
because it's just that we've like not been taught really that well about the like
Yes,
the symbols and
yes,
what
yes,
they're like used for.
yes, yes,
Okay,
definitely.
so this is like a typical series circuit.
Yes. Okay. Uh, okay, one more thing
Okay,
before.
this is.
Yes, yes.
No, no, it's fine. You can continue. It was just like me drawing it. Yeah.
Okay. Now, I was asking, like, do you know what's voltmeter and ammeter?
I know like the symbol for it, but I'm not really sure too much what its role is. But it's like a circle, and it's usually in circuits, aren't they? And
Yes.
then another B circle. But no, I don't know like what the role is or anything of it.
Yes. So A is ammeter. That means it's the instrument that is used to measure current. Because ammeter, you can remember it. Amps, ampere is the unit of current. So ammeter is that instrument which is used to measure current in a given circuit.
Yeah, yeah. Okay, yeah. Now, yeah. So like ammeters used to measure current, and voltmeters used to measure volts, right?
Yes.
I guess in like in a circuit, like what I mean by like the role is like more like how they work, like that's the part I'm not really sure of. Like we've made a few circuits like here and there, like basic ones, so like I know that like isn't like I'm not sure if they're the same, but like ammeter, like you read off of it, like it's like thing in a circuit. So
Yes.
and same with voltmeter, right?
Yes. So in series circuit, the most important thing is the current remains the same throughout the circuit and through every component, which is, for example, suppose 10 amps of the current is the total current flowing in a given circuit, then the same amount of current, that is 10 amp, will flow through this bulb and will flow through this bulb. That means current remains same throughout the circuit.
Okay, so nothing can change the current in the circuit. So current remains
Same.
throughout the circuit.
Yes, in series circuit.
Oh, yeah, series circuit, sorry. Throughout, yeah.
And in parallel, sorry, and the voltage is the total voltage. That means suppose this is 20 volts of total voltage, or total potential difference is 20 volts. Then 10 volts, or say for example, it's not necessary always 10 volts. You can say here it's 15 volts here, and then it's 5 volts, which means if you add up the voltage of every component, you will get the total voltage. Okay.
Oh, yes. Okay. So basic like 15.5 here. So like let's say if there was another one, then let's say if it was like 5, 5 and 10, so it would add up to 20 volts.
Yes. So you can say I equals
So
I1 equals I2. So current remains same throughout the circuit, And total voltage is equals to sum of the potential drop across every component. So V equals V1 plus V2.
Okay, I'll write that in a second. But so like 20 V, so like all the so the total voltage is um the total voltage is when all the components in a series circuit,
Yes.
like I don't know how to word it. Like when all the like meaning like does this more make more sense if I say when all the components in a series circuit, when all the voltages of the components in a series circuit adds up to the total voltage.
Yes, you can say the sum of the potential drop across every component is equals to the total potential drop.
Okay, so the total voltage is when you were saying, sorry, I couldn't like get all of it at once. So the total voltage is when,
You can say total voltage is equals to sum of the potential drop across every component.
okay, sum of potential drop
Yes, across every component.
across every component in a series circuit.
Yes.
So basically, the current always stays the same throughout a series circuit, and the amps, like the ammeter, like that's like what I mean is like the amps, like the current, it's not gonna change, so it's gonna flow the same throughout every component.
Yes.
But the voltage equals to the sum of potential drop like across every component in a series circuit.
Yes.
Okay.
That's good.
Yeah, I've copied it down.
And if you have to
Wait,
calculate, yes, yes.
sorry, do I need to like copy also? Should I probably copy down the current equals to I
Yes.
one? Yeah, so it's like, should I just, okay. So that basically means that,
Current remains the
um,
same.
yeah, and then the total voltage equals to, yeah, V1 plus V2. So this is like what it's meaning above. Okay, yeah.
Okay.
Yeah.
So the resistance here, equivalent resistance. So first of important, the total resistance of a given circuit. How to calculate the total resistance in a series circuit? It's R total equals R1 plus R2 plus so on. How many resistance are there? You just add up all of them. It will give you the total resistance. So suppose R1 is the potential resistance of this lamp or this component, and R2 is the resistance of this component. Then total resistance is R1 plus R2.
Okay, so you're saying like, let's say if, okay, so the total resistance, but the way you would find out the resistance of each one is that you would like if this like current was given and the volts were given, then to find out the like resistance, let's say, then you would do the you do the what's it called, you do then R
1
equals to
plus
this
R2.
divided by, no,
R2,
but like
yes, yes.
to find like R1, right? So like, let's say if you'd have to find the resistance like in the circuits, and it would give you this, so like 10 amps and like 15 volts and whatnot, would you then do to like find out R1, you would do 15 divided by the 10, wouldn't you?
Yes.
Okay, so this is like how to find out also the resistance of each component.
Yes, and if it's not given, like then to calculate the total resistance, it's R1 plus R2.
Okay, so if it's not given, then you just put R1 plus R2 or however many. Uh,
How many resistance are there? So like the questions are generally calculate the total resistance of a given circuit, and they give you R1, R2, R3. So since in series circuit it's R1 plus R2, so you just have to add them all. It will give you the total resistance.
okay. And if they're like, even if they're like, find out like R1 and R2, right? And then find out the total. So what is the total resistance? So at the side, I'd just be like, V equals to IR. So then like just to like R equals to V over I, right? So, and just like separately for them, and then once I find out, like if I find, like if in the question I need to find it out, and once I find it out they ask the total resistance, then I'll put this equation, like however many resistances there are, and I'll do like, let's say I don't know, like 5 plus 2 plus 3, so on, right?
Yeah, or there's a simple way if you have to calculate total resistance. The total resistance is if you know the total potential difference, total current, directly you can do 20 divided by 10. It will give you total resistance. So total potential difference divided by total current will give you total resistance.
Okay, so if I just need to find the total resistance and not each individual one, like not each individual for each like part, then if only like
Like if they have
needing.
given you the total potential difference and total current, then this is the way to calculate total resistance. But if in a given question no voltage, no current is given, only the resistance of a given components are given, then you have to calculate R total by this formula.
Okay, so wait, so what are you saying, that is like would this come up that I'd have to find the resistance like in a series or parallel circuit? Like what do you mean? Like I didn't hear the last part.
If in the question total voltage and total current is given to you and total resistance you have to calculate, use this formula. That is R equals V over I. But voltage,
Okay, but that's like total, right? Isn't it though? Like I'm saying like so that would be like, so what I'm like asking is basically if I'd have to find the total,
yes,
right? I then do like the volts over the ammeters. So but then if I'd have to find, then like what I'm trying to say is the R total, like the formula down there, R1 plus R2 and things. So don't like whenever before like I'm working something out, usually I'll like need to write a formula before it. But when I'm working out the total resistance, and if they give me the volts and like currents, and I'm supposed to find out the resistance, the total resistance. So if I do R total equals to R1 plus R2, so on, like, and if it like is quite a big circuit, you're saying I should just do then 20 over 10, like the total, or
yes,
like for whatever,
yes.
like the total. But then wouldn't the formula look different though? Like the formula, I wouldn't be using the same formula, would I?
No, no, no. It depends on what parameters are given to you. If voltage and current given to you, then directly use V over I. But if resistance are given to you, then use R1 plus R2.
No, but like, yeah, obviously classes if it's given, but if it's not given, and if I have to work like if it gives me the total resistance, like I mean the total voltage, the total current, right? So if it's like 20 and 10, but it tells me to it tells me to just figure out the total resistance of the circuit, right? So
Yes.
then I would do R total, but then like should I then find out R1, R2,
No, no,
R3
no, no.
individual,
No, no. If they are
or then
asking,
should I just do 20 divided by 10?
yes, 20 divided by 10. If they are asking you to calculate total resistance, why to go for R1 and R2?
But then, like, wouldn't it be a different formula for 20 over 10? Like, that's what I'm saying. Because, like,
Because
for R1,
it's V equals RI. We are using Ohm's law.
yeah, so that's like what I'm saying. So, do I put that, like, before, like, when I'm writing 20 divided by 10?
Yes,
So,
V
that's what.
equals RI. Yes.
Okay. Okay, so that's clear. So, this the only time I'd use, like, R total is if they, like, when is, like, when I would use the R1 plus R2? Like, if,
If
because
it's given as that
it give me.
the resistance of the lamp 1 is 20 ohms, resistance of lamp 2 is 30 ohms, they are in series circuit, calculate the total resistance. Just add them.
Okay, okay, I understand now. Right, okay, so is that because, like, I remember I'm just like slightly that's why I was confused because, like, when we were doing this topic earlier and, like, on, like, in the year, then, like, we were told, like, another type of, like, resistance type equation, but I think, like, that teacher just made it confusing and things, and, they're not teaching anymore at our school, so maybe it's because it wasn't efficient, like, maybe the studying from, like, from physics there, but that's why I was just like a bit confused with it because
But
for
it's
the resistance
okay. Yeah, it's okay.
equations, because I remember, I don't know if it's this exact one, but I remember there's also one which, like, the total resistance equals to, I think, R1 R2, like, an R2 over, like,
Okay, so
something
if
something.
okay, so if you're saying like it's 1 over R1 plus 1 over R2 that you're saying,
um I think so, yeah, I think that's like what it was as well, so
or
that's why.
there is another way. Wait a minute. It's like R1 R2
Yeah, yeah, that's what I mean.
by R1 plus R2, right?
Yeah, so timesing and then plusing.
Yeah, so this is for parallel circuit. We are doing series circuit as of now. There are different formula to calculate total
Okay.
resistance, one for series and one for parallel.
Okay, yeah, that's probably then I was probably just a bit mixed up with them, but yeah.
Yeah, so we are just doing series circuit as of now. Okay?
Okay, yeah, yeah. So yeah, I've written it down now, like, what difference, like, where like, formulas I'll need to use, like, for different questions.
Yes.
Okay, so what do we do next then? Is it the parallel
Uh,
or
I,
is
I,
it more?
I'm giving you a question on series circuit so that you do not get confused. Okay?
Okay, okay.
Okay.
And one more question, like, not to do with this, but see that, like, long line and small line, does that have anything to do with where you're placing things, or no? Is that
Yes.
just like
If this is a
circuit?
long line, that means current will flow from this point. It
Okay,
denotes
so
a higher
it
potential
short.
and this denotes a lower potential.
Okay, yeah, that's just so, like, I know a bit about it. So that's higher. I'll just write higher P and lower P. Okay.
Yes.
Okay. So what's the question, or are you still writing it?
Okay, that's the question I've completed. The question given is that there is a battery, it gives 10 volts of potential difference and the total resistance of this circuit is 5 ohms. Okay, so 10 volts is the total
Yeah.
voltage, this is the total resistance. Potential drop across this component is 3 volts, they are connected in series. You have to calculate R1 and R2.
Okay. Well, since the I need to find the currents of it, wouldn't I?
Yeah.
So because of because of that, like um I'm thinking then current, voltage, ohms. So then I need to do I. So V equals to IR first, or I, and then I do I equals to then like um I equals to V over R,
Yeah.
and then I need to do, since I is equal to 10 over 5, right?
Yes.
So that should be 2.
Yes.
So because 2 is the current, right? So because 2 is current, then like throughout how like in a series circuit current stays the same.
Yes.
So because it stays the same, then I would just like, I know that both currents is 10A and voltages. So 10, to find the missing volt would be 10 minus 3, right? So then
Yes.
that would be 7 volts. So then R1 would equal to, so that would equal to um 7
Yes.
or 7 over I mean sorry 7 over uh 10.
Two. 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 I is two.
Oh sorry. Yeah. Yeah, that's what I mean. Sorry. Hmm. But and then wait, I is 2.
Yes. 10 divided by 5. That you have done, right?
Oh yes. Sorry. Yeah. So 10, sorry 2, and then 7 divided by 2. So that's, yeah, 3.5
Yes.
um 5 ohms. And then for to find R2, all you'd have to do there is do 3 divided by 2, which is 1.5 ohms. Is that correct?
Yes. So, and you can even cross check it like R should be R1 plus R2. So, what 3.5 plus 1.5 gives you 5 total current. Okay.
Yeah. Yeah. Okay.
So, that's,
Right.
yeah. So, we have done series circuit, and the thing is, time is almost over. So, if we do the parallel circuit, it will take a whole 15 minutes again. So, we have to do parallel circuit tomorrow. Like if we do physics, then tomorrow we'll continue with this topic. Or if it's maths, then we'll do in any other class.
Pardon, I can't hear you. Like, I don't know, the volume's really low. I can't hear anything.
Can you hear me now?
A bit clearer, I guess. I'm just like, I have my volume full up. I think it's just maybe it's like, it's just going slowly.
Okay, so I was saying like time is almost over, and if we move on to the parallel circuit, then it will take 15 to 20 minutes, like 10 to 15 minutes, just like it took with the
Yeah.
series circuit. So we'll continue in the next lecture that I was saying.
Yeah, I mean, it's good. Like, even if rather, taking time, as long as like the understanding is like clear, that's, I guess, an
Yes.
important thing. So it's fine to do it like next time. You
Okay.
can do it.
Okay then. Thank you.
Okay. Right. Thank you so much. Bye. Have a nice day. Bye.
Same to you. Bye.
You are currently the only person in this conference.